Hey guys, this is the second experiment of uh, Internet Protocols Lab, and the title for this is Multipath Ospf, or we can simply say it as multi-area Ospf. So, uh, the Ospf link state routing protocols has a special feature named as areas. So, as you can see in the topology here, just a sec. Yeah, as you can see in the topology here, uh, these circled areas are different. These circled regions are called as different areas. So when you're talking about OSPF, we separate each of these regions as separate areas, and then we provide the necessary values. So for the description part, as I already said, OSPF link state routing protocol uses the concept of areas, which are subdomains within the OSPF domain. So OSPF is what we saw in the previous experiment. So here we are gonna see the multi-area concept of OSPF. So a router within an area maintains the complete topology information of that area. That is, in this case, a router in this area, like suppose this router is in this area, router 6 is in this area, so it will have the information of this area. Similarly, router 0 has is included in this region, so it will have the information of this entire region or this area. Other than that, by default an interface can only belong to one OSPF area. This can not only cause suboptimal routing in the network, but it can also lead to other issues if the network is not designed correctly. That is for description part. When multi-area adjacency is configured on an interface, the OSPF speed in adjacencies, the OSPF speeders from more than one adjacency over that link. Okay, so as you can see, this entire topology is divided into three areas. So let's see how it works. So just to make it visible, yeah. So one more thing is that the multi-area interface here is a logical point-to-point uh, point-to-point interface over which the adjacency is found. So okay, so let's see the scenario. So here we have three areas, as I already mentioned earlier. So we need, as we already always do, we need to perform some functionalities. So I have already set up the components. Now we need to see how it works. So let's take this router. Just a sec. Yeah. So let's type in some commands like let's first enable this, and then let's see the IP protocols which is used here. So as you can see here, this shows that when we are declaring this thing I mentioned earlier. So like, to make it more clear, I will show it to you. Config. So here we can type in the commands. It's router SPF. So here, like I have already done this earlier, but I'm just showing it to you so that you can understand how I did it. So router SPF1. So further configuring it, we can set the ID. So router ID. So we are setting this router ID to some value, say okay. Now we need to set the network. Like here we have three other components. So we are setting the areas for other three components connected to this router. Okay. So let's set the network and the area. So for setting the network and the area, we have network, then the address. So here we have 10 dot 0 uh, and then the subnet mask. So this is the subnet mask. 250. Now we have to give the area. So let's say this is the area 1. So area 1. So let's see if it's yeah, it's already accepted. So that is for 10.0.1.0, which is over here, like this component. Now the other component attached is this router. So let's give the network and this too. So here we have 10.0. 10.1.2. so here we can do it as, and we'll do it in the same area. So yeah, that's it. And then what else is attached? This router is attached, so we have to give it diff for that also. So network, and I'm entering these values based on the table, or which we like based on an IP address in which you have already allocated. So let's take 190.168.10.0 space 0 3. Okay, so this is for this area. Okay, so let's do the area number. So area 0. So this is also data accepted. So let's exit the configuration process. So when you see let's exit that too. So yeah, so if we try to see the IP protocols again, it will show it as Ospf 1 and all the areas that we have entered earlier. So that's how it works. Just I did it again just to explain it to you. So other than this, we can also see the IP routes, like how the router has its IP routes in the network. So let's see that. So here you can see that we are taking this router. Okay, so this router's address is subnetted, and it also shows in how many subnets it's subnetted. So that's how it works. And other than this, we can also have some functionalities like show IP Ospf. So as you can see here, what this basically does is it shows the entire details of the Ospf regarding to that particular router. So here, as you can see, it shows the minimum intervals, number of external bits, and then interfaces, authentication processes, and so on. So in short, it shows the entire details. And then we can also have something like every Ospf, as I already told you, Ospf is about finding the shortest path, right? So when we are trying to find the shortest path, we need to maintain a database so that we remember that what was the last shortest path we took. Okay, so for this we have one, we can see the Ospf database. Yeah, so as you can see here, for this router here, over here, router 0, this is the database that is recorded. Okay, so here as it is given here, it includes values like checksum, link ID, and how many its sequence number, and so on. So that's the commands, that's the functionalities that we are seeing here. So that's the main functionalities covered in this experiment. Thank you all.